Hello, everyone, and thank you for joining. My name is Bryan Reinero. I am a product manager at Sumo Logic, and the area of focus for myself is collection. And this, of course, is the area of our product concerned with getting data that's generated at your sources, which could be logs, metrics, traces, getting that data, collecting it, and getting it into Sumo Logic, where you can perform searches and perform analytics and get the value that you need out of the data that you're collecting. Now, when we think about a collection system that's enterprise grade, you may already think of some characteristics of a good collection system, which concern throughput, certainly, reliability, fault tolerance, and extensibility. But enterprise grade collection systems also need to give you controls on how much ingest that you're bringing into the system and give you a system to be able to monitor and be alerted when you're exceeding those expected ingest volumes. And that's precisely what ingest budgets does. This is a feature that we introduced about 18 months ago. And the idea here is that our customers needed to have controls to help deal with certain situations that would happen again and again for them that would lead to unexpected spikes in ingest. These kinds of situations would be things along the lines of a development team is performing load testing. And the result of that load testing is it generates a lot of logs, a huge volume of logs, more than expected, and that gets ingested into Sumo Logic and blows up the budget. Another scenario might be that a development team has released a new version of their application code. It goes out into production. It's subject to production loads, and they've left the log levels at debug verbosity. So these large amounts of debug logs come into the production servers, and it's brought into the system, and that can exceed budget. In these circumstances, users need some kind of control to be able to set a threshold, a maximum limit. And in some cases, they need that ingest to stop when that limit is exceeded. Or in other cases, they just need to be notified when that expected ingest goes over that threshold level and receive an alert, receive a notification that can take action to remediate this. So the basic idea with ingest budgets was we give the users a system to define a budget, define those caps, and the system has worked very well. Teams can utilize ingest budgets to avoid those unexpected spikes. They've also been able to use ingest budgets to control costs per team, which is a very important thing for large organizations which may be sharing ingest for a centralized account. If you're a large enterprise, you have multiple teams. Each of these teams have independent ingestion needs, and you want to keep costs controlled on a per team basis. Ingest budgets works great for that. Also, it's very important in the case of monitoring new workloads. And perhaps you've introduced a new stream of data into the system, and you're not exactly sure how much data that system is going to create. So you create a budget just to keep things in the safe zone, or even be notified if this new source of data should create more than you expected to come in. So there's a lot of good feature and value in ingest budgets. Since that initial release of ingest budgets, we found that the users need a little bit more degree of flexibility in how they define the budget and the data that they're going to define a budget on top of. So to give you more clarity about how this works, the first version of ingest budgets, a user would declare a budget, say how much they would like to keep that budget capped at. And then when they create collectors, they assign those collectors to that budget. And all of the data that flows through those collectors is subject to the control of that one budget. All of the data that comes in is tallied, aggregated, summed at that single budget. And when that budget is exceeded, all of those collectors will be stopped. The collection off of all of those collectors will stop or be alerted if you're running in that mode. What we found is that in many cases, our customers use the same collector to collect data from a lot of disparate sources. And these are different workloads, and they need different budgetary constraints, which require a finer grain resolution or finer grain budget declaration than at the budget at the collector level. So Version 2 of ingest budgets, which we have just recently released to beta, is a new system that allows you to use metadata tags to define the scope of what your budget should apply to. This allows you to go at a finer grain detail than just at the collector level, but allows you to define budgets at as low as a level as an individual source, or to be more accurate, the stream of data. So let me show you some examples about how this works. So as an example, let's talk about one of these scenarios that can lead to unexpected spikes in ingest. This is a true story. A customer had told me this had occurred to them in the real world. And what happened in this particular case is that, as you can see here, this particular customer had two basic environments. One was the production environment, where real world data, business critical data, was being ingested, and it was critical to keep that data flowing into the system. And then, of course, they had pre-production servers where they would do things like performing load testing, do development of their new applications. They would also do staging, pre-production stage testing. These pre-production servers would create data that was useful for analysis during the development phase, but it certainly wasn't critical information that had to be ingested into the system. Their expected load was about 100 gigabyte per day on average. That's what they budgeted for. And this is what they had set their account for. Now, what happened here is at the beginning of a 3-day weekend, a long weekend, the development team developing a new version of their application had a set of development databases connected to their application servers. And in order to save some money, they shut off the database instances for the duration of the long weekend. But what happened was the application servers were still left running, and they're trying to connect to these backend databases, which aren't there. And as a result, they're throwing all these exceptions, dbconnect exceptions, which get logged into the logs that get ingested into Sumo Logic. And this ballooned the volume of logs that were coming into the system and pushed them well over their expected ingest and caused some overages. Now, when people got back from the long weekend, they realized what had happened. Certainly the teams took remediating action to stop the situation, but no one wants to be in that position. No one wants to cause this kind of a problem. So this is exactly the kinds of scenarios in which our customers need some controls to keep this from happening. So let's replay the same scenario now with ingest budgets and show how we can avoid this situation. Now let's go back and we take a look at those pre-production servers. We notice that the app team that's developing this new version of the app system, they are already using metadata tags, which are tagged to each log record that they send into the backend system. They're tagging it with this key value pair. App team equals catalog development or catalog dev. This is how they route data within Sumo Logic. This is how they move data into partitions and declare FERs and search. This is how they identify their data when they're using it in Sumo Logic. And since they're already using this metadata tag, what the administrator or the application team can do is they declare a new ingest budget, and the matching rule that the budget operates on is a scoping rule that matches on this very same key value pair. So any data that comes in with that tag is going to be controlled by that budget. The amount of data coming in is aggregated and summed by that tag, by app team equals catalog dev. So when the case comes that the budget is exceeded, the budget stops, ingestion stops, and only data that's tagged with that particular key value pair will be stopped. All the other ingest keeps coming on in. And if we take a look here, you'll see this is an example of what the declaration of an ingest budget looks like in our system. And this is the new budget window. I've kind of graded this out so you can see the scoping rule that we use where all the magic happens. So in the background is the scope information, the scope editing window, in the background is the budget information window, the budget editing window. And I've pulled forward the scoping rule, and you can see The scoping rule works the same way as any other scoping rule inside of Sumo Logic. It matches on that key value pair app team equals catalog dev. So very simple. So there's two modes in which ingest budgets work. For pre-production, non-critical data, such that you would get in test, dev, staging environments, you may wish to run your ingest budget in drop data mode, what we would call stop mode or drop data mode. And you see in this example that the user has set the limit to 20 gigs per day. And after that budget has been exceeded, ingestion stops for all of the data tagged with that key value pair. Now, you may already surmise that it's a different case. You're not going to be in a position to be able to just simply drop data if budget goes over the expected amount for a production load, right? And you can see our production servers, they're dealing with mission critical data. We can't say no, even if the budget is, or even if the ingestion is spiking beyond what our expected load would be. So in this case, we recommend using ingest budgets in audit-only mode. The same declaration of what a threshold would be in the budget applies here. The difference is when that budget is exceeded, you get a notification or an alert that the budget has been exceeded, but ingestion doesn't stop. It continues to come in. This is pretty handy for understanding when you've gone over an expected limit, but you need to keep the data coming in. Again, this is also good for those situations where you're ingesting a new data load and you're not exactly sure what the daily limits should be. So you can set an alert notification if it goes over your expectations. In these circumstances, everybody's far happier. With these controls, everyone feels much more comfortable about expanding use and expanding collection of data into Sumo Logic to more teams, because now the controls exist to keep everybody safe and ingesting without going into overages, where these, for production loads of new teams, you can see when something goes over your expected limit. And the safeguards are in place that expansion is now viable and safe and sane. And that's kind of the key takeaway with ingest budgets. Oftentimes there's a desire to pull more data in to Sumo Logic across more teams within your organization. Ingest budgets give you the confidence to expand that collection by giving you controls to avoid problems and overages. So it just smooths out the whole situation in a very nice way. Now, the examples that I showed earlier, they work on custom metadata fields. This, again, was a feature that we introduced about 1.5 years ago. And custom metadata fields allow you to define key value pairs in a taxonomy that makes sense to your organization. You can come up with a set of fields and values that you would use to define data and map it to organizational structures, team structures, application names. But for many of our customers, of course, they're using our built-in metadata fields. Most famously among them is source category. Many of our users still use source category to identify their data. And of course, ingest budgets will work on that as well. So whatever the metadata field is, you can utilize it and you don't have to declare new fields to use the system. An interesting feature of ingest budgets is it has a wildcarding feature inside of it. So in this example, you can use wildcards to match a number of different metadata fields or source category fields in this example. Anything with a prefix in this case that says app team /catalog, as long as the field has that prefix, this budget will apply. So you can apply a budget that goes over many different source categories. Now, what's particularly useful about this is you can actually use two budgets in combination. You can use the wildcarding feature and another set of budgets to actually set up team or hierarchical budgets. Say if you wish to give a team a kind of a overall budget, and then they can subdivide those budgets into, dev, test, stage, prod sub-budgets as well. So there's a lot of flexibility in there about defining budgets and keeping teams under control. Another great aspect of the ingest budget system now that it uses metadata is this, of course, the same metadata that you would use to search on in the search window, as you see here. So where this becomes in particularly handy is, let's say that there's a set of data that has caused a budget to be exceeded in the limit. You got the notification that a budget has been exceeded. You've been alerted to it, and you want to go take a look and see, well, what kind of data are we dealing with? Why did that come in and go over my expected limit? And so you simply just search by the same metadata that you used to declare the budget, and bingo, it appears in the search window, and you can get some idea of what kind of data has gone over the limit. Another important component to ingest budgets is that whenever a budget is exceeded, or actually even before we get to a budget, we'll even put in a warning notification as well. The warning notification and or warning event and the budget exceeded event are both logged into the audit index as an event that you can query on. So retroactively, you can take a look and see when did something go over budget, and more importantly than that, you can also create a saved search that looks over the audit index. And when it picks up one of these events being sent into the system, this is how you would declare an alert and be notified that a budget has gone over its limit. So that's an important aspect for getting notifications. So the three main takeaways that I'd like you to internalize as a result of this presentation is that, number one, in order to avoid overages or unexpected spikes in ingest, use ingest budgets. That'll help you keep things under control. The new version of ingest budgets allow you to scope your budgets to the same metadata tags that you use to categorize, organize, and characterize your data. So that's our recommended approach now. It gives you fine-grained budget controls that give you a lot more flexibility that match the way that you think about your data. And then third is you can use multiple budgets to define budget hierarchies and create sub-budgets under perhaps a team budget is a pattern that would be very useful for our customers. And those are the three main takeaways. Thank you very much for your time, and we'll be following up with some Q&A.